Hi, my name is Nancy Searby. I work for NASA Earth Sciences Applied Sciences program. We're really excited to come here today and tell you about harnessing Earth observations for making programmatic decisions and responding to flooding events around the world. Today, we're going to tell you a little bit about what NASA does in Earth Sciences that might help you do your work. We plan to share what resources we have around flooding, as there are many more floods happening every day. We really think it's important that everyone knows that, in fact, we can share information about flooding with all of you. We'll be highlighting recent examples of how we've helped other people using our NASA-developed tools, and we hope that you'll leave this session with a little better understanding of how Earth observation applications might help you do your work. Today we have myself giving a brief overview, followed by Dave Borges providing a little overview on what NASA is doing in the area of floods, followed by Eric Anderson and Amanda Merkert telling you about the floods in Bangladesh and Cambodia, followed by our disasters program talking about examples by Guy Schumann, and finally I'll wrap up a little bit more about some resources we have that might be useful to you. So you can see us on the side of your screen, and now you can see us on this slide. I think you're going to enjoy our presentation today. We have experts from various different perspectives of our program who are excited to be here to share with you today. Next slide, please. So what is NASA doing in Earth science? I thought NASA only had astronauts and went to space and flew things to Mars like Perseverance. But no, actually NASA looks at the Earth too. So we have 4 different parts of our division. We have the part that builds the flight hardware, the satellites that look down at the Earth and make that data freely and openly available to you and to everyone. We have our research and analysis program, which is really trying to understand the Earth system. How does the Earth function? How is it operated in the past? And how is it changing in the future? Our applied sciences program is all about applying this knowledge of the Earth system to direct societal benefit. And that's why we're here today to tell you about flooding, because it's so important to be able to look at the Earth from the satellites and see what's going on in regards to flooding. Finally, we have a technology group that really works on the next instruments so that our next satellites can better understand the Earth. So this is just some of the ways we can look at the Earth. We can look at land temperatures. We can look at sea surface temperatures. We can look at how salty the sea is. We can look at how much it rains. We can look at sea surface height. We can even look at chlorophyll. Many different ways to look at the Earth through our different instruments. So how do we then take those perspectives of the Earth and bring it into applied societal benefit? We organize ourselves around the thematic areas that are most important to different sectors of our society. For example, we look at agriculture. We look at disasters, which we'll talk about flooding. And you can see our other areas there, including capacity building, to make sure people know how to use our information. We really focus on making Earth data accessible to all. You can see statistics of the number of countries we reached from our capacity building program last year. Pretty close to getting everyone in the world, but we still have places that we are trying to reach. And you can see that we've engaged more than 29,000 individuals and more than 6,000 institutions. We have different ways of working with people so that they can learn how to use our Earth observations. Our Applied Remote Sensing Training Program, or RSET, is a training program that any of you could participate in. There are on-demand webinars available, as well as live webinars that teach you how to use Earth observations to apply to different problems. We have our Develop program that's a 10-week program where participants 18 and up work with a user and develop an application of Earth observations based on that user's needs. I wonder if you could propose a Develop project and engage with us that way. Our Severe program, which you'll hear a little bit more about today, really works to bring space to village through a joint program with NASA and the U.S. Agency for International Development. So what do Earth observations have to do with floods? This is just a simple graphic showing that the satellites look down and the kinds of things that they can measure. So today we will tell you about some of our resources that can help predict, monitor, and understand flood impacts. Our next speakers will provide an explanation, highlight 2 case studies, and leave you with some resources and information to learn more. Over to Dave.
Thank you very much, Nancy. Hi all, Dave Borges with the NASA Applied Sciences Disasters Program. So in order to give a highlight summary of how and what NASA contributes to global flood awareness and action, I tend to like to start at the top. And for us, that means space. So the intent of this graphic is to just convey scope and the sheer amount of satellites that make up our Earth-focused satellite fleet. You might also notice that other national assets are included in this graphic as well, and that is because NASA maintains strong relationships with many other national space agencies and partners, which only increases the amount of global coverage data that we're able to bring to the table and leverage towards floods on a global, regional, and local basis. So this animation, which is our Global Precipitation Measurement, or GPM, is intended to convey that our entire flood-focused community here at NASA try our best to take a global and systems perspective. We're really interested in looking at the whole concept of any given situation. A simple example of this when addressing floods, for instance, is that while we'll jump into a couple of different specific categories of flood information that we share with the community. But if we're sharing something like flood extent mapping, we also like to integrate things like soil moisture. Pre-existing information like this is quite important in terms of flooding because it can heavily influence the actual severity of floods in different regions around the world. Here at NASA, we're also very much aware of the fact that accessing and using our data and information can be a bit of a daunting task for many, and this is a primary reason why our Applied Sciences program exists. Capital and programmatic investments are made by NASA to generate innovations and lower technical and institutional barriers to using the earth science information, data, and derived products. And while the flood community extends broadly across NASA, our disasters program is focused every day on working directly with disaster risk reduction and management stakeholders and partners to help integrate NASA technology into existing work streams and decision-making processes. So broadly speaking, 4 primary categories of flood products are shared out openly and freely by NASA with a wide variety of stakeholders. You can see here that this first animation here, which is flood extent from Cyclone Idai landfalling in Mozambique, is in fact flood extent. We have a variety of different data sources and output a variety of different data products related to flood extent, some which are tailored for certain areas. And the same is true for the others listed here, to include flood depth mapping, flood modeling, and latest developments in terms of integration of all of the above, from extent and depth and models as well. And finally, the fourth dimension here that we really try to address in direct partnership with stakeholders is risk. And risk is defined by the United Nations Office for Disaster Risk Reduction as the confluence of natural hazards, vulnerability, and exposure. So not only do we create science-based products like flood risk, but NASA actually also has very relevant data. One example would be socioeconomic data. So we are able to combine products like flood extent and flood depth with population data sets and other socioeconomic data that really help our partners and stakeholders address risk in various regions around the world. Going a little bit more in depth on our flood capabilities, flood preparedness and response capabilities include satellite observations, data systems, and modeling capabilities. And I've divided them into 2 core areas here. So the first one being global flood prediction and warning. An example that I've listed here is NASA in partnership with the University of Maryland, in fact, a global flood monitoring system. And secondly, global flood mapping and damage assessment. So not only do we create things like the example that's shown here is flood proxy maps, similarly, we create damage proxy maps as well that really, touching on risk again, integrate different data inputs such as infrastructure along with flood extent and flood depth to derive damage from critical infrastructure, among other things. I include this graphic because it highlights a couple of different things. First of all, what you're looking at is Hurricane Dorian as it's actually passing over the Bahamas, several islands in the Bahamas, and the blue layer that you're seeing within this spyglass here is actually flood extent mapping that we are able to derive from radar-based satellites while the Earth is still completely covered by clouds. So I include this because it, I think, highlights that we do have some amazing capabilities that we're willing and eager to share with partners and stakeholders, but there are limitations as well, things like sensor type. So as you can see with cloud cover here, optical data has certain limitations, like cloud cover, it can't see through clouds, and we try to work around that when able with solutions like radar data and produce, in this case, flood extent maps before a hurricane even finishes passing over a given geographical area like the Bahamas here. But there are other things to consider as well, such as spatial resolution, or how accurate on a spatial scale the output product might be, as well as latency. We do have a vast constellation of satellites, but there are limitations to understand in terms of how quickly you could potentially receive data for any given area in the world. So working with us is really the best way. That's why we're at this meeting, doing this outreach video, and we always welcome those interested to come work with us directly to learn more and learn how you can benefit from the types of applications that we work on every day. And I'll wrap up with this slide. This is just one example of a dashboard that we do share out on a regular basis within our disasters program. And the important thing that I want to highlight about this, other than the fact that our team does make some really cool looking dashboards, is it goes much beyond that. If you or someone in your organization simply wants to interact with this guided user interface, the technical level to do so is quite low. And we also work very hard to curate the content that we provide with relatively simple and straightforward descriptions of what you're looking at in dashboards and portals like this. And for those organizations that might have dedicated GIS and/or mapping departments, all of our data is available to be pulled into your own environments as well. So we try to serve a wide variety of partners and stakeholders in terms of the products that we share out with the community. And with that, I'll pass it on. Thank you.
Thanks so much, Dave. Hi, I'm Eric Anderson with the Surveyor program. Surveyor is a joint program led by NASA and USAID. Surveyor's capacity building mission relies on several things. One, a deep understanding of the decision-making challenges and needs in regions around the world. Two, innovative and cutting-edge science that are informed by free data from Earth-observing satellites, such as those Dave just shared with us. And three, strong and lasting partnerships. In this next short segment, we'll take you to two of our regions of focus, the Hindu Kush Himalayas and Lower Mekong. You'll hear directly from our partners in Nepal and their counterparts in the US on how we're working with flood managers in Bangladesh to co-develop actionable information about floods to improve preparedness and reduce overall risk. Following that, I'll send it over to Amanda Markert, who will share on some experiences in Cambodia. But first, let's hear about our projects and from our project partners directly about flood preparedness and early warning in Bangladesh.
The Hindu Kush Himalaya is a very fragile ecosystem where natural disasters has been the major concern and vulnerability of the people.
Every year they get flooded, about a third of the country. And some years about 2/3 of the country are flooded.
They are lacking of systems that can help them to improve the severe weather forecasting in the region.
They need to have advanced warning in time and place where floods might occur so that they can be better prepared and also more resilient after the flood.
So this is the first NASA applied science project to actually address extreme weather in the Hindu Kush Himalayan region and develop a solution for forecasting those hazards that are produced from the extreme weather.
So with this new system, every stream is mapped showing the red, yellow or green colors about the upcoming flood situation. So that gives an alert in a certain community that there could be a flash flood in the next 48 hours time.
Before, they might only have an hour or two of lead time. They might have up to 6 hours or 18 or even up to a day's lead time where they can see a flash flood occurring in a smaller basin and be able to provide similar kind of advanced response and then preparation for mitigation afterwards. The motto in Severe is to take space to village. We know space pretty well and we know how to take those models as scientists. We've developed ways to use that space information to create flood modeling, but to get it to the village, we really need to have their context. We need to know what their problem is in order to be able to define a solution that meets their needs.
What's innovative is that we're taking a continental transboundary approach to hydrology. And so we know that water knows no political boundaries. Whether countries decide to share information with each other is one question, but can we use the scientific method to estimate how much water is flowing over an entire continent and help those people that don't have access to the information?
It's very honoring to be working with top-notch scientists of NASA as well as the renowned universities in the US. Also being able to really look into the problems that are being faced by the people in our countries, that gives a really satisfying moment to the work that I do.
I'm excited for a future where every institution, every hydrologic, meteorological service and disaster management agency has access to adequate information to make informed decisions, because I know that this will save lives, it will save property, and it will improve the quality of life for the people who are served by it.
We hope this short video demonstrated the importance of partnerships and building trust. Behind collaborations like these in Severe is cutting-edge applied science and Severe's commitment to build capacity in the mandated agencies, regional and national agencies, to reduce flood impacts. From a scientific standpoint, this project in Bangladesh focused on forecasting river discharge and stream flow with more lead time. And with more lead time and accurate data, communities stand to benefit from anticipatory actions to reduce flood impacts. We'll now talk about the opportunities we've discovered on leveraging long histories of satellite data combined with near real-time flood mapping, again, to better equip countries and communities to prepare for floods. And for that, I'll pass it over to Amanda.
Thanks so much, Eric. Hi, everyone. I'm Amanda Markert. I work with the Severe Mekong Hub. To talk about flooding, so as the previous video just showed, within Asia, there's a lot of concerns for flooding. And when we have floods, these events tend to impact infrastructure and make it very, very difficult for people on the ground to identify where there is water and then who is affected. In addition to that, in these areas, we're seeing increased rainfall, more frequent flooding. And so it's increasing this demand to get these flood maps to help people identify where water is faster. As Dave also just showed, when we have clouds over an area, it makes it very difficult to rely on one of many different remote sensing techniques and satellites available. So leveraging multiple different satellites and the data that they produce is very critical. However, there are limitations in being able to do that to fully leverage all the data. So to try and work towards addressing this challenge, Severe Mekong developed the Hydrologic Remote Sensing Analysis for Flood System. The system is fully cloud-based. It leverages many different sensors from many different satellites and fuses them together to generate near daily water maps to help put these maps in the hand of end users. This whole system is fully publicly available. It's open source so that others can take it and they can replicate it and use it for their own needs. HydroFloods itself, it does generate these maps, but we're generating these maps in an automated manner to address flood preparedness by providing high demand flood mapping in a quick, near real-time manner. For HydroFloods, the key engagers recently have been our work with a group called the World Food Program. They have a system called PRISM, which is a platform for near real-time impact and situation monitoring. This system allows them to better assess natural hazards and the impacts on the ground. So Severe Mekong is working directly with them and integrating the data, the maps from HydroFloods into their systems in Cambodia and Myanmar. So I want to walk you through a recent case. So as I mentioned, Severe Mekong is working in Cambodia with World Food Program. In October of last year, there was a large flooding event that unfortunately led to the loss of over 42 individuals and affected over 175,000 families. In events like this, the Cambodian government and partners that they work with, such as the World Food Program, work to manage flooding and monitor it over very large areas, and they have affected over 1 million people. In these types of situations, it's very critical to put near real-time data to put these flood maps in the hands of responders. So Severe Mekong, through their collaboration with World Food Program, aided in some of the response to these floods. So as I mentioned before, data from HydroFloods, it's automatically pulled into the World Food Program's PRISM system. It was used to actually generate a series of situation reports that World Food Program used and disseminated to help coordination with other relief agencies and the Cambodian government during this event. And one of our World Food Program colleagues stated HydroFloods made it possible to produce estimates of the population affected by floods to guide the immediate response, while field assessments were still being conducted and information formation of a more comprehensive response plan. So with that, I'll move on to my final slide and conclude Severe's work. So Severe, as Eric showed in the use case in Bangladesh, and then also what was happening and supporting the Cambodian flooding, Severe works to support flood preparedness and resilience. We do this through tools like stream flow prediction tool, like HydroFloods. We further achieve this through leveraging forecast data to look forward into the future to enable forecast-based action, but also automate generation of flood products to help reduce the barrier and put these data in the hands of stakeholders. Everything we've built is very much scalable so that others can take it and replicate it. And then also we try to make sure to build capacity of other users so that they can take it and own it as their own and use it for their own applications. So with that, thank you, and I'll pass it on to our next speaker.
Hello, my name is Guy Schumann, and I'm with Remote Sensing Solutions in the US, and I'm a PI or principal investigator of some of the NASA disasters programs. So I'm going to give you a few examples here of ongoing projects and show you a bit the data that's been used. So just to recap what Dave has been saying earlier, this is the main portal that the program has to offer a whole bunch of data going from precipitation, soil moisture, but even things like microwave remote sensing or radar remote sensing of river systems and discharge even. I'm going to show you some of that later. But again, at this portal, the dots you see is basically an activation of a flood event where NASA was either requested to call in and respond, or the programs that they have in terms of projects, they are helping responding as well. So as you can see, the whole world is covered, but just a quick note here, we don't cover all events, also because of current limitations of sensors, like Dave was also mentioning before. But this just gives you a good example of what's possible, and the portal is really easy to use for non-experts. So here, just one nice example, and I have to be honest here, there are many more projects going on, so I had to pick a few here. This is one example of NASA's engagement with the GEO program. So it's a group on Earth observations, international group. The link is here below. You can find a lot more information on the program. But essentially, here's an example of responding to Cyclone Eloise. So this is not EDI. Unfortunately, it's the exact same location that was hit in this year, in January. So here we were able to use sub-daily discharge alerting from microwave remote sensing. So that's basically a radar system from space that is able to gauge rivers for discharge volumes, and a sub-daily, so I think twice daily coverage, so able to give a bit of lead time for people. That was joined with information from MODIS, an optical satellite that NASA has that is able to map floods also twice daily. Because of that coverage, it's able to actually remove clouds on a weekly basis. So that's also joined from data using the SAR system. So this time it was a European Space Agency system, Sentinel-1, for event mapping at a bit higher resolution and seeing through clouds. And in some cases, not in this particular case, but in Hurricane Harvey, for example, we're also able to use commercial satellite data, such as from Planet, Cloud3, and other systems to complement that data. So if you can imagine that all these data sources can be put together and give you much more actionable information on the ongoing flooding that you see, and all of this is actually done from space at various resolutions and various time steps. So here, a quick other example. I think this is a great project to showcase the actual integration of models and Earth observation. As Dave also mentioned before, this is one of the possible ways to get more information out of the Earth system than just through one of them alone, so either models or data. This is actually joining both sets. And here, a quick example of the massive pluvial floods, so rainfall-induced floods that happened in Africa in 2020, where a lot of countries in the Lake Victoria Basin got affected, and almost 1 million people got displaced. So here, a system that NASA is building with the Pacific Disaster Center and many other institutions linked to this project, able to use open available global forecasting models like GLOFAS, run by the European Center for Medium Range Weather Forecast, and NASA-supported global flood monitoring system into what we call a model of models. So it's actually using a couple of models, but it's trying to integrate all of them so that in the end, you only have one model that is able to alert, predict, and even joint with observations from satellites then to zoom into location for situational awareness using those available observations. So in this project, we also use, as I said before, for the other project, we use here also SAR, so radar plus MODIS, and NOAA satellite sensor, also optical, called VIRS. We use those observations to then zoom into an area basically that we have alerted and predicted using models to actually zoom at the local scale to really see what's going on in terms of impact. And this image below here shows an example of such a classified radar image on top of Google Earth map of the Democratic Republic of Congo, a country that's most often left a little bit behind in terms of observations, also because of the problem of course, the jungle area there, covering all of the river systems at the floodplains. So SAR is also able to see through the vegetation, not only the clouds, but also the vegetation. So I think these are two examples of where NASA is trying really hard to get the whole community together, whether you talk modeling, observations, in situ even, to integrate all this information together. And this is all available also in the disasters portal system that we showed you before.
Thanks, Guy, and thanks everyone for a great snapshot of the different kinds of activities. So would you like to learn some more about what we're doing? I recognize this is just a short teaser to show you all the different kinds of ways that you might be able to use Earth observation information in your work as you're working in places that might become flooded. Here's a list of different flood-related resources. You've seen the disasters mapping portal referred to several times. So definitely that's a place to go to get a sense, as Guy just showed you in that last picture, of what's going on around the world with flooding. And you can go ahead and observe those projects and those models and the results yourself by just visiting that website. We also have data centers all around the United States that serve our NASA free and open data from all our different satellites. And our data centers have developed something called a Floods Data Pathfinder. So maybe you are a user that might have a little more knowledge and skills, and you'd like to be able to go get your own data sets to be able to put a tool together to meet your particular needs. So the Floods Data Pathfinder is set up to inform you on how to find the different data sets you might need to put together your own tailored application. We also have an Earth Data Floods Toolkit that provides similar kinds of tools that you might be able to use to put together to address floods for your particular application. I mentioned Applied Remote Sensing Training, or RSET. There are many disasters trainings available, including ones focusing on floods. And as I said earlier, they're available on demand, so you can watch them if they've already occurred, or there are trainings that are actually given live that have question and answers and homework, and you can earn a certificate. So depending on your particular interest, even if you don't know anything else, you want to go take an introduction to remote sensing training, you can go do that tomorrow if you're so interested. You heard two examples of Severe's work, but in fact, Severe works in multiple service areas. So if you're interested in Severe's flood work, you can go to the service catalog and find the way to filter on water and water-related disasters. And you'll see all the projects that are going on in development services, as well as services that are more mature, as we just heard about. Our Develop program has many projects. Again, those are 10-week projects, sometimes in the United States, sometimes international, working with participants from the United States or partners internationally. And there are multiple projects that are listed and are identified under disasters. All of these resources will be available through our virtual booth, as well as we are having a learning session. Next slide, please. So our Learning Lounge comes up right after this is presented to you all. And the Learning Lounge starts at 2 p.m. Eastern Time, and it's called Earth Observation Tools to Respond to Floods. What are they? Where are they? And how can you use them? So this was just to give you a taste of the kinds of information that will go into much more depth in the Learning Lounge. And so please do join us there. It will be a live session, and you'll be able to ask your questions and share your interests and your needs. And maybe you've tried to use some of this information, and in fact, it didn't meet your needs. We'd love to hear that. We really want to understand what are your pain points, what are the barriers to being able to use this information, and really, what are your hopes and dreams? Boy, if you would just be able to show me this, I could really meet the needs of the users that I'm working with from my nonprofit organization perspective much better. So please come to Learning Lounge. We'd really like to hear from you, and we want to share more about this information. With that, I think we're done for the day. Thank you so much for participating and listening to this session. We have a website on the Applied Sciences program that's shown here, and it includes our capacity building program, our disasters program. You can find all the information you might want to find by starting with our website. So this is Nancy Searby saying thanks for joining us, and really look forward to seeing you at the Learning Lounge. Thanks a lot.